All right, last question from Catholic High. So we are given a table, right, of the mass of various carbonates and the mass of this carbonate remaining at the end of the heating. Using relevant information, determine which carbonate is the most thermally stable. So we're basically going to look for the one, right, that has no change in the mass. So it didn't break down at all, is the most stable carbonate. So from the table, it looks like carbonate 2 is the most stable. They say the metal in carbonate 3, right, has an ionic charge of +2. By means of a calculation, identify carbonate 3. Okay, so we need to do some calculation. The mass loss is 0.7 grams. So the number of moles of carbon dioxide that was lost is 0.0159. This will be the same number of moles of metal carbonate. The MR of the metal carbonate, you take mass, divide by the number of moles, you will get the MR. Okay, so just take this MR minus off carbon, minus off 3 oxygen, you will get the AR of the metal. So having known the AR, just go to your periodic table to see which element correspond to this AR. Okay, so the answer here is zinc. Explain why the mass remaining at the end of the reaction is different for each carbonate. Okay, so this really depends on how many moles of carbon dioxide, um, which equates to different mass of carbon dioxide gas evolve, right? Yeah, so is due to their different MR. Okay, last question. Carbonates of mercury and silver decompose to metal on heating. Write the chemical equation to show the thermal decomposition of silver carbonate. Okay, so this is just a equation. Make sure that you balance it properly. Suggest the position of mercury relative to copper in the reactivity series. Explain your reasoning. Okay, so